Hi, good morning to all. In this session, we have to discuss about petroleum and refining process. So first, we have to classify the fuels. So primary fuels which are occur in nature, that means petroleum, natural gas are available in Earth's crust. Directly we are obtaining from the nature, that is called as a primary fuels. Secondary fuels means that fuels are extracted from the primary fuels. Secondary fuels are not available in nature, but we can extract that from primary fuels. So examples are given: coke, gasoline, coal gas, etc. Both these primary and secondary fuels further divided based on their physical state, whether they are solid, liquid, or a gaseous form. So calorific value is a total amount of energy liberated by when a unit mass of fuel is burnt completely. When we burnt when we burn a particular volume of the fuel, how much amount of heat is liberated? That is called as a calorific value. The units, if you heat required to rise the temperature of 1 gram of water through 1 degree centigrade, that is called as a calorie. So the amount of heat required to rise 1 kilogram of the water to 1 degree centigrade is called as a kilocalorie. That is 1 kilocalorie is equal to 1000 calories. And as per British thermal unit, the quantity of heat required to rise the temperature of 1 pound water to 1 degree Fahrenheit is called as English system unit. Next, come to the liquid fuels. Petroleum products are called as the liquid fuels. They are occurring in Earth's crust under the sea surface, and they are useful for domestic and industrial fields. So next, petroleum properties we have to discuss. Petroleum or a crude oil, a dark greenish or a black colored viscous oil. We are separating this oil from the Earth's crust. This oil is floating over the brine. And this crude oil is made up of paraffin, olefinic, and aromatic hydrocarbons. And sometimes it may have nitrogen, oxygen, sulfurs. The composition of the crude oil is given here. So carbon is presented from 80 to 87%. Nitrogen maybe 11 to 15%. Sulfur maybe 0.1 to 3.5%. Remaining 0.1 to 0.5% are nitrogen and oxygen materials. So now we have to start the refining of petroleum. Crude oil is obtained from the Earth's crust as a water and sulfur and oil material. That means that crude oil is contains a mixture of water, sulfur, and some unwanted impurities. First, we have to separate that oil from the water. After that, we have to remove the harmful impurities. Then we have to process that crude oil into fractional distillation. After that, we have to separate each fraction depending upon their boiling point. This is the refining petroleum process. Then, this refining of petroleum involves 3 steps. First step is separation of water. So that oil and water are mixed together. Initially, that crude oil is in the form of emulsion, that is oil in water. We have to pass through the charged electrodes. We have to pass this emulsion through the charged electrodes. Then water has been removed, and then oil is free from water. But it may have some salts, maybe sodium chloride, magnesium chloride, which can corrode the refining equipment. So we have to remove those things. Then we have to remove the sulfur by treating them with the copper, and that sulfur has been removed as a copper sulfate, and then they have removed by filtration method. Then that crude oil is now heated up to 400 degrees centigrade, whereby all the volatile substances start to evaporate. That these vapors are passed through the fractional column. This fractional column is very tall, and they are having a number of horizontal stainless steel trays at short distances. So these steels are having small chimneys covered with a loose cap. Now that vapors of this oil go up into fractional column, and then immediately they may get condensed, and they will be stored into separate chimneys. So the fractions are having a higher boiling point can be stored at lower chimneys, that means lower trays. So that fractions which are having lesser boiling points can be stored in upper trays. So based on their boiling point, that materials have been separated and they have stored separately. And then here that various fractions of crude oil and their composition uses are given here. So uncondensed gases below 30 degrees centigrade, uncondensed gases will be coming up below 30 degrees centigrade, and the composition of hydrocarbons are carbon C1 to C4. That means it contains 4 carbons, and then it is used for industrial purpose or LPG. Petroleum ether, so the fraction temperature is 30 to 70 degrees centigrade. So after 30 to 70 degrees centigrade, the petroleum ether starts to evaporate and it will get condensed, and it contains carbon composition maybe C5 to C7 as a solvent. Then gasoline and petrol, it starts to separate at 40 degree to 120 degrees centigrade. It can be used as a motor fuel, solvent, and dry cleaning. Next, naphtha or solvent split. It starts to separate 120 to 180 degrees centigrade. Contains 10 carbons, maybe as a solvent and dry cleaning. Then kerosene oil. This starts to separate from 180 to 250 degrees centigrade. So it contains 16 carbons, maybe, and these can be used as a fuel for jet engines. And then diesel oil, gas oil. So it starts to evaporate from 20 to 50 to 320 degrees centigrade. It contains 10 to 18 carbons and it can be used as a diesel engine fuel. And heavy oil, these oil will start to separate when temperature reaches 320 to 400 degrees centigrade. It contains 17 to 30 carbon materials, and it will be useful for production of gasoline by cracking the process.